In this example, we're told that a typical cup of coffee contains 100 milligrams of caffeine. So if you drink that coffee, the caffeine goes into your body and your body eliminates 16% of the caffeine every hour. So every hour, 16% of the amount of caffeine is metabolized and eliminated. All right, so we want to know after someone drinks a cup of coffee, how much caffeine remains in their body after 1 hour. All right, so let's call this function Q. All right, so Q after 1 hour, so Q of 1. Essentially, we're starting out with 100 milligrams of caffeine in our body, and then we're eliminating 16% of it. So 16% of 100 is how much is leaving our body, is being metabolized over that time period. So we're going to subtract this time instead of add. All right. So now I'm going to do something similar to what I did in the last example. I'm going to factor out that factor of 100 just so you can see another way to look at this. All right. So 1 minus 0.16. All right. So I factored out 100 and I end up with 100 times 1 minus 0.16, which is 100 times 0.84. So because 16% of the caffeine is leaving our bodies and we want to know how much remains, you can see that 84% of it remains. Okay, so I can go ahead and calculate that, and that's pretty easy. That should be 84 milligrams of caffeine is in the body after 1 hour if 16% is metabolized. All right, so let's do it for 2 hours. Let's look at what happens after 2 hours. Okay, so Q for time t equals 2. We're starting out with 84 milligrams now, and then we're subtracting 16% of 84 milligrams. All right, now again, I can write that as 84 times 1 minus 0.16. All right, but 84 is, I can actually substitute this in for 84, right? So I have 100 times 0.84, right? That is 84. That's where the 84 came from. And then 1 minus 0.16 is another 0.84. Okay, so I've got 100, let me write over here, 100 times 0.84 squared. Okay, so I'm just writing, I could have calculated it right off the bat, but I want you to see where the exponential is coming in. So when I put that into my calculator, I got 70.56 milligrams. That's how much should be in the body after 2 hours. All right, so let's do a similar thing for 3 hours. All right, we're starting out now with 70.56 milligrams and subtracting 16% of 70.56. And so we'll have 70.56 times 1 minus 0.16. All right, so again, I'm just going to take this right here and put it in for the 70.56 because that's where it came from. And so I have, let me write it down here, I have 100 times 0.84 squared and then times another 0.84. Whoops, 0.84. All right, so I have 100 times 100 times 0.84 cubed now after 3 hours. All right, now I can calculate that value. What did I get? I got 59.27 milligrams. All right, so now because of all of that writing that I did, which I'm sure seemed unnecessary, but that was really to help us see what the function would look like. So you can see I have, let me pick up a highlighter. I have 100 times 0.84, and then I have 100 times 0.84 squared, 100 times 0.84 cubed. And so if I want a function Q of t is just equal to the initial quantity times 0.84 to the t. Okay, so the thing to watch out for this in this problem, you know, is 16% is being eliminated, and we want to know how much remains. So if 16% is eliminated, then 84% remains, and so that's why we're multiplying by 84%. All right, so that's our function, and I will meet you in the next video.